Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's presentation on normal distribution. And coming to the overview of today's presentation, today we will discuss the introduction to normal distribution, what is the normal distribution definition, the probability, standard normal variate and standard normal distribution, and normal curve and properties of normal distribution. So, we are going to discuss about these topics today. Now, coming to the introduction part, the normal distribution is a continuous probability distribution. In the previous sessions, we have discussed binomial and Poisson distributions, These two distributions are discrete probability distributions, whereas the normal distribution is a continuous probability distribution, So, normal probability distribution or simply normal distribution is the probability distribution of a continuous random variable capital X, defined by, this is the notation, here we use the notation capital N of x bar comma sigma given by 1 by sigma root 2 pi e power minus 1 by 2 into multiplied by x minus x bar whole square by sigma square. So, this is the probability function in normal distribution. The normal distribution is also known as Gaussian distribution, and this theoretical distribution is the most important, simple and useful because the binomial and Poisson distributions can be approximated by normal distribution. Not only that, the sampling distributions like t distribution f chi-square tend to be normal for large samples. So, if the sample is large, all these sampling distributions tend to normal distribution. And then normal distribution is applicable in statistical quality control in industries. So, that is why this is very important and useful distribution. Now, the probability in normal distribution can be calculated using this formula. For example, this x is the random variable. In general, we denote the random variables by capital letters. So, if this x follows, we denote capital X as a random variable, and if this x follows normal distribution, this is called normal random variable or normal variate. So, to find the probability of this normal variate lies between two values. So, that is probability of x1 less than or equal to x less than or equal to x2. To find this, simply integrate the function between the limits. Since it is a continuous probability distribution, here we use the integral notation. So, probability of x1 less than or equal to x less than or equal to x2 is given by integral from x1 to x2 1 by sigma root 2 pi e power minus this one, which is the probability function in normal distribution. So, by finding the integral value of this, we can find the normal probabilities. This is the usual definition. But here what we use is, to find the probabilities, we use the normal distribution table, which is calculated for standard normal variate values. So, that is why this is also called standard normal distribution table. And that standard normal variate converts x value to z value. This x is the normal variate, and this z is standard normal variate. So, we convert x to z and then we use the normal distribution table to find the probabilities. So, this is in fact only the definition, and we do not use this to calculate the probabilities in normal distribution. Simply we use the normal distribution table. Now, how to convert x to z? This z is the standard normal variate given by z equal to x minus x bar by sigma. Here x is the normal variate which we are going to convert, and x bar is the mean and sigma is the standard deviation of the distribution. So if we have x bar and sigma, we can convert x to z using this formula. This is called standard normal variate, and the table was constructed for these standard normal variate values, z values. So the standard normal distribution. Now here z is x minus x bar by sigma. In the probability function of normal distribution, here we have a term called minus 1 by 2 x minus x bar whole square by sigma square. So here we have this x minus x bar by sigma. So if we replace this term by z, then the probability of z is given by, since sigma, root 2 pi, all these are constants, we can write outside integral 0 to z e power minus z square by 2 dz. So simply here we have replaced that term by z equal to x minus x bar by sigma, and this gives the probability of z. Similarly, if you want to find probability of z lies between two values, z1 and z2, simply integrate z1 between z1 and z2 f of z dz. F of x is the probability function of normal variate, then f of z is the probability function of standard normal variate. So to find the probability that z value lies between two values z1 and z2, simply integrate from z1 to z2 f of z dz. That gives the probability that lies between two values. Now coming to the properties of normal distribution. The graph of normal distribution is called the normal curve, and here the normal curve is as shown in the figure, and this curve is in the form, for example, let us consider x-axis, y-axis. Now this curve is in this form, it tends to infinity, it never touches x-axis, either positive x-axis or negative x-axis. So the graph of normal distribution is called normal curve, and normal curve is symmetric about y-axis. You see here the symmetry, the shape of the curve, half left to y is same as right to y. So this portion is same as the portion that lies on the right side of y-axis. That is called symmetry. It is bell-shaped curve. The shape of the curve is bell-shaped. So the normal curve is symmetric about y-axis. It is bell-shaped curve and unimodal curve. Unimodal means the mean, median and mode all coincides. The mean, median and mode of normal distribution coincides. So the mean of normal distribution is mu. So we will get the same for median and mode also. So if all these three values are the same, that means coincide, then the curve is said to be unimodal. Next, normal curve has inflection points at x bar plus or minus sigma. So inflection point, that means the point at which the curve changes its convexity to concavity or concavity to convexity. That is called point of inflection. And for normal curve, the point of inflections are given by x bar plus or minus sigma. Next, it is asymptotic to both positive x-axis and negative x-axis. And the main important property is area under the normal curve is unity. So that means, again, let me draw the normal curve, x-axis, y-axis. So for example, origin. Now the area under the normal curve, this area, this total area is equal to 1, is equal to 1. So the area under the normal curve is unity, and since the curve is symmetric about y-axis, so this half portion is same as the remaining half portion, and we know that the total area is equal to 1. So here area or probability both are one and the same. So finding the probability of z lies between two values means the area that z lies between these 2 points. So probability or area both are one and the same, and since the normal curve is symmetric and total area under normal curve The total area under normal curve is unity. So this total area is unity, this total value is equal to 1, and since the curve is symmetric, the left side portion is equal to right side portion. So this will be 1 by 2 half, and similarly this right hand side portion also 1 by 2. So therefore we can write the properties, the remaining properties as, similarly if we consider of x and y axis, this is like this, otherwise z and f of z. So I can consider the graph for z and f of z also. This is z axis and this is f of z axis. So 0, z1, z2 and so on, minus z1, minus z2 and so on. So under standard normal curve. So the probability of minus infinity less than z less than plus infinity. That means the total area minus infinity to plus infinity f of z dz is equal to 1. The total area under the normal curve is unity. Next, the probability of minus infinity less than z less than 0 is equal to probability of 0 less than z less than infinity. That means this negative portion is equal to the corresponding right positive portion, and each is equal to 1 by 2 because the total area is equal to 1 by 2. Similarly, the next one, the probability of minus a less than z less than plus a. Let us consider a value minus a to plus a. So for example, if you draw the graph, you can identify the region clearly. So let us consider some plus a here. This is a. So this is minus a. Now we need to find the probability or area that z lies between these two values. So this is the required region. But we know that between negative and positive we have 0, and the negative portion is equal to corresponding positive portion since the curve is symmetric. So this can be written as, so integral from minus a to plus a f of z dz, which is 2 into integral 0 to a f of z dz. Similarly, probability of z greater than some point a, if you want to calculate probability of z greater than some point a. So let us draw the graph and consider some point a here. Now we need to calculate the probability of z greater than a, that means more than the values, more than this a. So this is the required region. So this is same as finding the area that z greater than a, or integral from a to infinity f of z dz. So we need to calculate the integral from a to z, a to infinity f of z dz. But we know that from 0 to infinity the area is equal to half, 0 to infinity. So 0 to infinity f of z dz minus, we can calculate this area from the table 0 to a. So integral 0 to a f of z dz, and we know that this half positive portion is equal to 0.5. So 0.5 minus integral 0 to a f of z dz. So like this we can calculate the probabilities. Similarly, if you want to find probability of z less than a, so here a is a positive value. If you draw the graph, you can identify the region. So a is a positive value, so right side z f of z 0. So this is a, for example. Z less than A means we need to calculate this region, complete left side region to A. So that means to find minus infinity, here minus infinity to A, f of z dz. So this is equal to minus negative to positive will have 0, f of z dz plus 0 to A f of z dz. So we know that this part is equal to minus infinity to 0, half, the area will be half. So 0.5 plus 0 to A f of z dz. So we know that this region is 1 by 2 and we can calculate this region using the distribution table. So by adding these two, we will get the area here, the area right to A, probability of z greater than A, and here 12, probability of z less than A. Similarly, if the value is negative value, z greater than minus A, the value is negative. So let us draw the graph. Negative value, so denote here 0, z f of z, this is z f of z. Now we need to find the probability or area that z greater than minus A. So that means the right side area to this minus A. So minus A to plus infinity f of z dz. We need to calculate this value. Negative to positive, there will be minus A to 0 plus 0 to infinity. And we know that 0 to infinity f of z dz, this is half, area is 0.5. And this area we can calculate using the table. So like this we calculate the probability of z greater than minus A. Similarly, probability of z less than minus A, the value is negative and we need to calculate the area z f of z 0 minus A, left side to minus A. So that means we need to calculate this region. But we know that from minus infinity to 0, the area will be half. So this can be calculated. Minus A, z less than minus A means minus infinity to minus A f of z dz. But this is equal to minus infinity to 0. So this total half region is 0.5. From that, if we subtract this region minus A to 0, minus A to 0 f of z dz, that gives the remaining area minus infinity to minus A. And we know that this value is equal to 0.5 minus A to 0. Using the standard normal distribution table, we can find this value. So like this, we can calculate the probabilities using the standard normal distribution. And also the mean of normal distribution is mu and variance of normal distribution is denoted by sigma square. So the actual values itself. The mean of normal distribution is denoted by mu and variance is denoted by sigma square. And in today's session, we have introduced the normal distribution, which is a continuous probability distribution, and this x is called normal variate or normal random variable, and we convert this x to z, which is called standard normal variate, and this is normal variate. So the probability function in normal distribution is given, and using this z we can convert x to z using the formula x minus x bar by sigma, where x bar is the mean and sigma is the standard deviation of the distribution. And also we have discussed the properties of normal distribution, which are very important to solve the problems. if you understand the properties of normal distribution, yes, we can calculate the probabilities using the normal distribution table. And the normal curve is symmetric about y-axis, and it is a bell-shaped curve, and the total area under the normal curve is unity. So that means this negative portion will be equal to half and the positive portion will be half. So like that, we have discussed some properties of normal distributions. So in the next session, we will solve some problems on normal distribution. Thank you very much, and we will meet in the next session.